Alright, 8.5 rhombi in squares. The objective in this is actually wrong. Instead, students will be able to recognize and apply the properties of, should say rhombi in squares to solve problems. Sorry about that, typo. And a rhombus, this is a quadrilateral with all four sides congruent. That means that all the sides are the same, similar to a square, but the rhombi doesn't have to have right angles. And I looked up the plural because I wasn't sure, but you can say rhombi or rhombuses. It's actually, they're both correct, so it's fine. Let's learn about some theorems here. First theorem, the diagonals of a rhombus are, well, take a look. Looks like we have 90 degrees in here, and we call that being perpendicular. So the diagonals of a rhombus are perpendicular. And if the diagonals of a parallelogram are perpendicular, then it is a rhombus. So if we ever get diagonals that are perpendicular, and if we already know it's a parallelogram, then it's definitely a rhombus. Alright. This one says, each diagonal of a rhombus bisects a pair of congruent opposite angles. Alright, so what that means is this diagonal here bisects this angle so that these two angles are exactly equal. And these two angles are exactly equal. And these two angles to start with were already congruent because it's a parallelogram, so that means that all four of these angles are equal. And all four of these angles are equal. And all four of these angles are equal. So we have three sets of four congruent angles. Well, we're going to use that information to solve this problem. It says find all the values of the numbered angles. Well, take a look at it, see what you think. Right away, I see we have these two angles. Well, this is a diagonal of a rhombus, so these two guys must be the same. So angle 1 is 78. And angle 4 has got to be the same too, because all four of these angles are the same. Alright, so we have two of them. And then remember that the diagonals are always perpendicular, so that means this is 90 and angle 2 is 90. And so is this angle right here, which means I have two angles of a triangle. So 90 plus 78 is 168. Subtract that from 180, and I get angle 3, which is 12 degrees. Alright. I found all the angles of a rhombus. Alright. Let's talk about the next step here. Alright, so we have this statement. It says, if a parallelogram is both a rhombus and a rectangle, then it is a square. And I'm going to put square exclamation mark. Okay. So, if it meets all the requirements, well, at least one requirement of a rhombus, because we only need one to prove that it's a rhombus, and it meets one requirement of a diagonal, that means it's a square. So, with that information, let's go on to the next problem. So, here they give us some coordinates, and we're going to graph those coordinates. So, the first one is at 1, 3. The next one is at negative 3, 1. Next one is that C is negative 1, negative 3. And the last one is at 3, negative 1. Alright. And we're trying to determine whether or not ABCD here is a rhombus, a rectangle, or a square, which it says over there on the left. So, let's first check and see if it is a rectangle. The way we do that is we check the diagonals. And if the diagonals are congruent, then it's a rectangle. So, let's take a look. Let's draw out those diagonals. Alright. Now, if I wanted to, I could take the distance formula, plug these points in, or I could do what I've been showing you guys is the shortcut, where you can just kind of count how many you go over left and right, and how many you go over up and down, and then you would say, hey, AC is the square root of, I went over 2, so 2 squared, plus I went up and down 6, so 6 squared. Well, 2 squared plus 6 squared, that's AC equals 4 plus 36, which is 40. And I could simplify that, but I'm not going to bother yet because all I'm really trying to do is find out if it's the same as BD. So let's take a look. Well, to get from B to D, I go down 2 over 6. So if I was to do BD, it would be the square root of 6 squared plus 2 squared. Well, what do you know? I'm going to get the same thing, right? 36 plus 4 is 40. So let me zoom out here. We just calculated the distance of the diagonals, and we found out that they both equal square root 40, so we know that AC is congruent to BD. Therefore, it is a rectangle. We put a little therefore sign. Therefore, it's a rectangle. I'm going to say check. We know it's a rectangle. Alright, well, now we need to figure out if it is a rhombus. So we got this a rectangle, but how do we figure out if it's a rhombus? Well, remember, if it's a rhombus, then the diagonals are going to be perpendicular. Well, let's find out their slopes. Once again, I can just take a look at AC here, and I could count the rise over the run. Well, this rise is 6 again, and its run is 2. So I'm going to come out here. I'm going to say the slope of AC, it's my little shorthand for slope, I just made it up, is rise of 6 with a run of 2, which is the same thing as 3 over 1. Okay, now let's calculate the slope of BD. Well, you probably don't need to zoom in, but remember, it went down 2 over 6, so we would write negative 2 over 6. And that reduces down to negative 1/3. And we learned a long time ago that if slopes are opposite reciprocals of each other, opposite meaning they have different signs, and reciprocals meaning they switch, so 3 over 1 switches to 1 over 3, then they are perpendicular. And these definitely are. So we can say that AC is perpendicular to BD. That means it is a rhombus. Alright, so we know that it's a rhombus, we know that it's a rectangle. Well, if it is both of those things, then that means it is a square. So that's how you check and see if something is a square. You check to see if it is both a rectangle and a rhombus. Okay, this was really just kind of a discussion question. I wanted us to look at it, but I'm just going to walk you through it real quick. It says, discuss with your neighbor, the infield of a baseball diamond is a square, as shown below. Is the pitcher's mound located in the center of the infield? Is it in the center? Well, here's the idea. So all the sides are 90, and it says from first to third it's about 127 feet, 3 3/8 inches. So let's just say 127 feet for now, just for estimating, because this distance from home plate to the pitcher's mound is 60 feet, 6 inches. Well, let's think about that. Half of 127 is about 63 and a half, right? 63 and a half feet. Well, that's more than 60 feet 6 inches. So this is not halfway across. Therefore, therefore it's not in the center. That's all it really takes, right? Because this would have to be more like 63 feet from home base to be right in the center. So that's all. So we could just say no. It's just one that I had us talk about in class. And lastly, the summary is something that we talked a little bit more about because I really want you guys to see it. It says, make a Venn diagram showing the relationship between parallelograms, rhombi, rectangles, and squares. Well, think about this, guys. All of these shapes are parallelograms. So I'm going to make this big box, and this is going to be my parallelograms. Okay? And then inside there I have rhombi, and I have rectangles. Right? And then the overlap of both rhombi and rectangles, that's where the square is. So I'm going to just put a big S for square because I don't think I could fit it there. But so there's where my squares go. And that would be a Venn diagram that shows the relationship between the parallelograms drawn by rectangles and squares. So there you go. Just wanted you guys to see it. Take a look. There's the information. There's the notes for 8.5. See you guys later.